video ran too long, so I'm starting it up here. All right, so now RB, we can break that out. We can break it out thinking of it this way or this way. I total is still true here. I total is still true here. All right, we have a voltage drop, plus minus, plus minus. We have a voltage drop of 8 volts across this, across this. That means this point here that equals 2 volts. There's 2 volts from here to common. From here, there's 2 volts. From here to here. It's the same circuit, same answer. So that means I have plus minus 2 volts across those values. Or you can look at it here, plus minus. There's 2 volts across these. It's the same answer, it's just 2 different ways of looking at it. So that means RA has 2 volts on it. That means R4 has 2 volts on it. Okay? So that being said, I can then find the current because of Ohm's law. So the current of RA is equal to VRA divided by RA. And VRA is 2 volts. And RA is equal to 1K. So is R4. So I come here and I say 2 volts divided by 1K, 1e to the 3, 2 divided by 1e to the 3 is equal to 2 milliamps. All right, and then IR4 is equal to VR4, box that answer, divided by R4 is equal to 2 volts, because they're in parallel with each other, and they happen to be the same resistance value, so the math was easy for me. I take those values and I plug them in. 2 milliamps, 2 milliamps. Amps is already up there, so I'm going to put an A there. But here's the thing. Kirchhoff's current law says that current is divided. So at this point right here is this point right here. There's a choice for the current. The current can choose to come down here or go this way. And it's a little easier to look at it this way. It can go this way or this way. Up until this point, it's the total current, IT. All right? Here, it changes and becomes IR4. Here, it changes, becomes IRA. We calculated it to be 2 milliamps and 2 milliamps. I total is 4 milliamps. So the sum of these two adds up to the total because it recombines here for I total. Okay? Here is IR4. Here is IRA. They recombine to become I total. All right? So that checks off. So what do we mean by that? So 2 milliamps plus 2 milliamps equals 4 milliamps. IRA plus IR4 equals IT, which happens to be the total current coming into this combination. And that's true. And that's Kirchhoff's current law. All right, so we checked out. So then our next step is to come up here. I already know total current, IT. I know the voltage drop across here. I know the voltage drop across here. I know the current through here, IR4. I know the current through here is IRA. And the total voltage across this setup I know to be 2 volts. but I want to know the voltage drop across these 2 points. And this IRA is the current that's running through them. That's the total current. So I can take the total current here and transfer it to 2 milliamps. 2 milliamps. There's 2 milliamps running through R2 and 2 milliamps running through R3. Okay? So that's that setup. So Ohm's law, we can use this table for Ohm's law, and so we'll do that. So R times I equals V. So VR2 is equal to I R2 times R2, which in this case is equal to IRA times R2. VR3 equals IR3 times R3, which equals IRA times R3, which is equal to 2 milliamps times 500 ohms, 2 milliamps times 500 ohms. And it's like I did it to be easy. So 2e to the negative 3 times 500 is equal to 1 volt. 1 volt. 1 volt. Box those answers. And so I put 1 volt, 1 volt. So I have a log of my information, but that makes sense. I have 1 volt dropping across here. I have 1 volt dropping across here. And that is a total of 2 volts across this total distance. So RA is 2 volts. And so Kirchhoff's voltage law holds true. So I write that over here. 1 volt plus 1 volt equals 2 volts. VR2 plus VR3 equals VRB. And that's true. And that's Kirchhoff's voltage law. Boom. So I've now solved this circuit, used a couple pages to do so, and I'll let you take a look at that for a quick second. But this was a video longer than I anticipated them to be, but it's what it is. Thank you very much.